Hello everyone. So, in this video, I'm going to present about my report writing for subject MTS 3203, Mathematical Reasoning. First of all, let's start with our profile. The presenter for this video is me, myself. My name is Ryan O'Neill Anatep, student from class Mat 2, PISMP, intake August 2023-2028. This project is a group project and my group member is Tan Kian Hao and Tuan Muhammad Arif bin Tuan Zuzaman. So, first of all, for the introduction, I'm going to talk about mathematical reasoning. In simple terms, mathematical reasoning is all about thinking logically to solve problems. It involves representing pattern and relationship in data, which help us understand how things are connected. We also use structure steps like Polyar method that tackle problems systematically, and we find a solution. We justify it with evidence to make sure it is correct. Finally, mathematical reasoning helps us to think abstract ways working with symbol and concept rather than just number. In short, it's about using logical pattern and structured thinking to solve mathematical problems effectively. Now, let's continue on. I will explain the Polyar method. This is a 4-step approach for solving mathematical problems. The first step is to understand the problem. This means identifying what being asked and notifying any important information is given. Next, we need to devise a plan. Here, we think about the possible ways to approach the problem, like using a formula or breaking it down into smaller parts. Once we have the plan, we can carry out the plan by applying the chosen method to work through the problems. And finally, we can reveal the solution. This step is all about checking our answer to make sure that it is accurate, and then our step is made sense to us to understand it more simply. In short, Polyar method help us to tackle problems in a clear, organized way. Now, here is the problems example of a problem statement where I have provided. This question is about a trapezoid shape community park. Roughly, some information is, for example, 30 meter for the base and 50 meter for the base, and 20 meter of the height of the trapezoid park. Now, this problem statement consists of 5 questions. The first question, it asks us about the area of the park. And the second question, it asks us about the perimeter of the park. Now then, from the perimeter, we need to find the cost to build a walking pathway around the perimeter of the park. Now for the fourth part, it asks us to calculate the new area of the park when the park is extended 10 meters. No matter how it is extended, it's just being taught to us that the park is extended. Now, and finally, question number 5 is more about critical thinking, where we need to discuss what else of the benefit when we extend the park. Rather than the area become bigger, what else benefit we get? Now, for the first solution, we will try using algebraic substitution. Okay, first and foremost, we need to list down all the information. For example, here I have stated be the information that is given For example, like B1, B2, H, L, and C is the information that is given. Now, from that information, we can answer the first question using algebraic substitution, where we just apply the formula and substitute the value that has given to us into the formula. And finally, for the area, we can get the answer of 800 square meters. Secondly, the question asks us about the perimeter. Same as the first question, just use the formula and substitute the value. And for this part, the answer is 130 meters. Now the third part, from the answer 130 meters just now, we knew that the cost is $5 per meter. Just times that with the perimeter, and finally we get the answer of 650 meters. $650. For the fourth part. So for this part, we are required to count the area when the park is extended 10 meters. Which means we need to plus 10 meter to the base. So the base 30 just now plus 10 will become 40, and base 50 just now plus 10 become 60. Continuing on for the section number 4. After we have plus the base, we just need to apply back the formula and substitute the new answer, which is the base just now. And finally, we get the new area of the park. After we have expanded it, will become 1000 square meter. Alright, after all the thinking of using algebraic substitution, now we will try using solution by drawing diagrams. Okay, first of all, here I have draw 3 diagrams which we will use to answer this question. Okay, so basically a trapezoid is made up of a square and 2 triangles. So that's why I draw a square and 2 triangles to become equal to a trapezoid. So the area of the square is 600, area of the 2 triangle is 200, and sum it up, we get the area of the trapezoid, which is 800 meters square. Now, for section number 2, where we are required to calculate the perimeter. So from this part, we need to draw out the area, draw out the layout of the park, so we understand which part that we need to add up to be the perimeter. So from this drawing, we understand that we need to have 2 legs, which is at the left side and the right side, and 2 base, which is the upper base and the lower base. So finally, we get the answer, perimeter equal to 30 plus 50 plus 2, 25, equal to 130 meter. So you can see the answer is exactly the same when using algebraic substitution method just now. Okay, for the third part, where we are required to calculate the walking path, calculate the price for the walking path. In drawing diagram method, we need to draw the imagination, where we imagine where is the walking path will be put. For example, here I have draw a dotted line around the outside, where is the perimeter lah. It's the perimeter around the perimeter of the trapezoid, and that is the total length of the walking path. So we know that the walking path is the perimeter, and then we just need to times with the price per meter, so we get the final answer, which is the same as just now, which is $650. And finally, we go to the fourth part, where we can see clearly by using drawing method. See clearly the extension of the 10 meter just now, where it went and how much has been extended. So by using drawing, we understand that it is extended to the right for 10 meter and extended to right for the 10 meter at the base number 2. So then we apply the same method using algebraic substitution. We substitute the value into using the new value that we have drawn out, so we can get the answer to be equal to just now, which is 1000 square meter. So for this section number 5, it's more about critical thinking. So we no need to use any algebraic substitution or drawing because it has no numerical information. Now, I have outlined some key consideration for designing the community park here. So first of all, a larger area in the park allow a space for activity like open market, playgrounds, and sport field, providing flexibility for various community events. On the other hand, a smaller area are perfect for seating, gardens, or intimate gathering, creating a cozy space for a relationship. Now next, for the landscape, it plays a big role in enhancing the park look. With thoughtful planning, we can add a green space and flower beds to make the park visually appealing and inviting. Alongside that, a drainage system is crucial to ensure proper water flow and avoid waterlogging, especially during heavy rain. This drainage system usually at the side of the park. In terms of seating layout, using a bench or picnic table will help us maximize the park space and offer plenty of option for people to relax and enjoy. Lastly, pathways are essential and it is important for accessibility, guiding the flow of movement through the park and improve overall ease of using the park. Therefore, this element will help to create a functional, beautiful space for everyone in the community to enjoy. Now, we have gone through all the solution and how to solve it. We understand that both solution is different. At the same time, they are similar. I briefly discussed the similarity and difference between using algebraic substitution and diagram for solving our community park problem. First, let's look at the similarity. Both method is using the same calculation, leading to the same final answer. We can see just now, every single answer is exactly the same. And then they both follow logical step-by-step solution, making sure we clearly understand each part of the process. Now, let's talk about the differences between these two methods. The algebraic substitution method, focusing purely on calculation without showing the layout, making it a faster and a more abstract approach. It's ideal for solving straightforward mathematical problems. In contrast, the diagram method provides a visually representation of the park. This approach will give us a better sense of the layout, including features like the walking path and expanded area. Through this method, more time is consumed to create the diagram. But the diagram also adds real world content to help us to visualize how each measurement fit into the park actual design. In summary, whether both methods are effective. While both methods are effective, the algebraic approach is efficient for quick calculation, and the diagram approach adds visual clarity, especially for practical planning. Therefore, I can say that the diagram method is more suitable for students under 12 years old, which is the primary school students. Alright, that's all for our video today. Thank you for watching. Goodbye.